Okay, so we are on 2021 here, 2021, paper 2, question 3A. So this is page 373 in the papers. So it says a circle K has center 1 minus 2 and a chord AB. Now, the minute I hear chord, I'm thinking the radius comes down on the chord at 90 degrees, and it also cuts the chord into two equal pieces. So even just that mention of the word chord strikes a chord with me. Excuse the pun. So it says circle K has center 1 minus 2 and chord AB, where AB is equal to 4 root 3. So 4 root 3 is the whole way across. So if I was to divide that by 2, 2 root 3 would be each piece. The 0.32 is the midpoint. So they've been good enough here to actually give this away. You should know 3,2 was already the midpoint, but anyway, they've told you, so we can be even more confident that 2 root 3 is the length from A to D and the length from D to B. Find the radius of K. So this is one of those situations where once you put in your radius, you get your 90-degree triangle and your right angle triangle, and you're going to use Pythagoras. Now, before I do Pythagoras, I'll need to get the length from 1 minus 2 to 3, 2. So that's x1, y1, x2, y2. So I have my y2 minus y1 to be squared plus x2 minus x1 to be squared. So that's going to be your 16. That's going to be 4. So that's root 20. Now, that's root 20. If that is root 20, I can now use Pythagoras. So we're looking for the radius of K, sorry. So I'll just keep it as R. So R squared should be equal to 2 root 3 squared plus root 20 squared. So R squared is equal to 4 times 3, and the root of root 20, square of root 20 is just 20. So R squared is equal to 12 plus 20. So that's R squared is equal to 32. So R is the root of 32. So that's what 2 root 4 is it? 4 root 2, sorry, 4 root 2. So my radius is 4 root 2. It says it should be in the form A root B, which it is. So we're happy about that. Also on paper 2021, paper 2, question 6, we got this diagram here, part B. In your exam papers, it's page 380. So in the diagram below, the lines PA, so we'll just focus in on them as we go, PA, HK, and BR are parallel. Okay, so these three are parallel. That's good news. Now, it says prove AH times QB is equal to AP multiplied by HB. Give a reason for each geometrical statement you use. Now, this may look a little bit confusing here, but really what they've done here is instead of, so it's going to be a similar triangle thing. I'm actually going to highlight the sides they're talking about just so we're focused on what section of the diagram we're interested in, because there's so many lines. So they've mentioned AH. They have mentioned QB, they have mentioned AP, and they have mentioned HB. So straight away, I think, well, hopefully you guys can see it too. It looks like we're interested in this triangle and then this one down here. Now, I know it's still confusing when you look at this. It's like how, multiplying, but this is actually the result of cross multiplying. Like if you think about it, the only way you could multiply AH by QB would be if originally AH was there and on the other side of the equals QB was down here. Do you get me? So that would have been as a result of cross multiplying. Now, if that was as a result of cross multiplying, then, well, what else was? Well, also we should have had BH down here somewhere and AP. So if you look at it now and you cross multiply, yes, does that make sense with the diagram? It does. Now, how did I know whether to put the BH or the AP in that position? Well, it's beginning to look apparent that really what they're asking us to do is similar triangles. And what I notice is that AP is in one triangle along with AH. So AP and AH, when I'm doing my similar triangles, shouldn't be on the same side. Do you know what I mean? Because if you pick AH, we'll mark in the angles now, but if you pick AH, you'd have to pick something in the other triangle that corresponds to it. So let's mark in the angles and it'll be easier for you to understand. So, for example, here we have vertically opposite angles. So we know that they're definitely the same. You know, why have they mentioned parallel sides? Hopefully at this stage in the year, the minute you hear parallel, you should be thinking alternate angles. So there's my Z shape there. So this purple angle here should be the same as this one here. And then of course, if two angles are the same, we have an automatic third angle is the same. Now, when we're dealing with similar triangles, what we're really looking for is that all the angles are the same. And that's what we found. So that's good news for us. So if we backtrack now a little bit, so AH is opposite the green angle. So if AH is opposite the green angle, then we need to divide him by BH. So while we figure that out looking at the statement, now we're doing it using similar triangles. So these are what we call corresponding sides. Okay. And actually, sorry, we were told to give a reason, so we better give our reasons. So we'll start by saying the measure of the angle PHA is equal to the measure of the angle BHQ because they are vertically opposite. So this is me explaining that I've seen that they are similar triangles. I'm going to talk about the purple ones. The angle PAH is equal to the angle QBH. They are what we call alternate angles. And then finally, the green ones, we can say that the angle HPA is equal to the angle BQH because it is the third angle in the triangles. So in other words, if the other two are the same, the third one has to be. So therefore, triangle AHP is similar to the triangle HBQ. And if they are similar, then that means what we're about to do here. AH divided by BH should be equals to, so now we're needing AP. So in other words, opposite the orange side in the big one, we have AP. Opposite the orange angle in the small one is BQ or QB. Now, when we cross multiply, we get the AH times by the BQ, just like we are told. And the rest of that then is AP should be cross multiplied by HB. BH, HB, that all means the same thing. And that's us done because we have said they're similar by AAA. And because they're similar, then we can, of course, pick out corresponding sides.